A cordial welcome on my behalf to today's Technology Day. Glad to be here on the other side, but it's really great to be here. Let's stick to the existing framework in the existing presentation with the sensational title, Fusion of Virtuality and Reality. In automobile production, there is a high degree of automation, and for us to understand this degree of automation better, let us look at the number of robots used. And if we look at Germany, we see that around 1,300 robots per 10,000 employees, compared to only 200 robots in all other industries. So this means that many machines and also PLCs are being used. To give you a better overview of the steps required for car production, let us take a closer look at the very beginning. Dr. Löser mentioned the press shop. The next step, they are welded and glued. They are controlled by laser management. If control is passed, some parts are installed, the doors, the bonnet, the boot lid, and once everything has been mounted, the car comes to the paint shop where it's cleaned, electrocoated, dried, primed, sealed, color varnishing takes place, then it's dried, and there is quality control of the varnish. After that, the car comes to the trim line, an assembly line with various stations, some automated, some manual. When parts are added, like carbon harnesses, pedals, seat belts, center console, and dashboard, then the windscreen is glued into the car fully automatically and camera driven, so that the windscreen is fitted to the fraction of a millimeter. Afterwards, the car goes back to the trim line where the seats are installed, and then, depending on what type of vehicle we are talking about, the batteries or the engine are installed, and then there is the marriage, when the chassis, so the undercarriage, the powertrain, the wheel suspension, the axles and the brakes is linked to the body. And once this is successful, the wheels and tires are fit and the car is then on its own wheels for the first time, and then can come for alignment and control to the roller stand. And after that, the car is finished. Now take a deep breath. 12 different steps, and you can imagine for the 20,000 parts to be installed and mounted, for the car to be ready, many more steps are required and many more PLCs are required. We can see those with the CODESYS, symbolized by the CODESYS runtime symbols. And in order to manage this numerous amount of PLCs and the data, we, 5 years ago, those of you who attended, including me, remember, showed you the Industry 4.0 platform, CODESYS Automation Server. Some time has passed. There was further development. The automation server is being used throughout the world in numerous branches. And now I would like to go to my presentation computer and show you some existing functions. So we switch to my presentation computer and we are on the surface. Currently it's cloud-based, browser operated. And for you to manage a controller, you have to link it up, which you do via network scan. Then you can pick edge gateways. These are services when where the controller network is linked. And here we have a gateway at our Kempten headquarters in a completely different network. And one edge gateway is in here. Here I have 4 Raspberry Pis with LED modules. We will then look at them later on in a live demo. Once I've checked or selected the edge gateways, I do a scan. Existing controllers are found in the stage and the company network, and these 4 controllers shall now be added to the automation server. Now it links up, and you see there's a runtime user management as a safety step. I authenticate myself with a safe password and username in the controllers, activate the option of application upload capabilities. I confirm that the automation server sends the data to the controller, checks my credentials, whether they are correct, and adds the controller to the automation server. Now the controllers are part of the automation server. In order to show networks, there are various options that you can have switchboard views or our own photos, or also the car production line can be shown. In these topology views, it's possible to use configurable items to change to other views. For example, by this leap icon, you can leap into another view. Via the CODESYS runtime icon, I can look at the detail of the controller and actuate the controller further. And it's also possible to use the group icon to go to the list view, where there is a list of filtered controllers. So let's take a look at that. Let's go to the list mode or view. We only see 9 controllers that have the feature PLCs in production line. Some are running, others not. We can also turn off the filter. Then we have the overview of all 22 controllers that are shown via the automation server. And in addition to the state, we can also see what applications are running on what application, on what controller, at what status, and we see the source code of the associated project. And this brings us to a new feature of the automation server we haven't seen so far, the project and application repository. This means the automation server is the central storage place for source code and boot applications, that is, machine code that can be executed on the controller. For example, we could use the drop-down menu to choose a certain project and open it by simply clicking on that button. Now it will be opened locally in the development system, later more. Another feature which is very often used and very popular, since it's extremely practical, is deployment to several controllers with few clicks. For that we go to the details. We see that the application was done for Raspberry Pi, and the automation server filters all compatible controllers into that list based on the criteria, and we see the application with the name Chromatic App. And here we see the demonstrator controllers. In order to feed that, some clicks are required. Select the controllers, confirm, and in the next step, the automation server will load the application to the controller. We can see in the web service that the application has been sent to the controller, and here you see that all the lights are turned on. This not only happens automatically, but this can also be scheduled. The typical use case is a machine is turned off at night, so you have the time to update the controller, but you don't want to sit at the automation server and press a button. For that, it's easy to make schedules, an update planner. Here, the mask is very straightforward, because also with the UI, we want to be as intuitive and as any possible in order to be self-explanatory, because we think that a UI is like a joke. If you have to explain it, it's no good. So straightforward. We enter a name. Let's call it Painted Black. Say in 2 minutes, so that we will still see that. We'll do an update, or We could also do it right away if there's a new version. We don't want to do anything if there are errors, because there will be no errors today. Then I select the project, the version, and the appropriate application. The list is filtered automatically, saving, and we're done. The update plan is there. We see that the application dark template is on 4 controllers to be uploaded at that time. And whilst the update is automatic, then I will continue. If the lamps are off, please clap or say "oh," because I will forget about it. But once an application has been loaded to an upload has been loaded to an application, there's a killer feature, and for that we go to the detail view, not in the network, but in my office. And with a click on that button, Login with CODESYS, it is easily possible to remotely link to a remote controller via the automation server and the Edge gateway. I have to authentify myself. Typing was easier yesterday when we did the rehearsal. Then I register, and I'm checked. Then a new folder can be created. Let's call it temp 12E. That might not exist. And now the automation server will save a local copy of the project on my PC, with which it is possible to log on to the controller. All the relevant information is downloaded. You can see the progress bar on the bottom left-hand side. Once the data is uploaded, there is a link with the remote controller. It knocks the door of user management. I have to authentify myself, and in the next step, once it is established this connection, there is a connection between my controller and the development system, and now we are linked to that control via the automation server, the Linux Edge gateway, and control is running. We can act as if we were locally accessing it. We can look at the control log, browse the file system, and also online we can look at the code. We can see live variables, and let me try a split screen. I can do now what we can also do locally: set a breakpoint in order to debug the application, and the automation server notices once it is stopped. Then there is the debugging mode, and of course this side, the page, knows what user is debugging the controller and gives me the option to end the debug session. And here you see in the development system that there is an appropriate message displayed that the link was disconnected. That was quite good what we've seen here. With one click, I locked onto a remote controller without having to deal with a VPN tool with a third-party manufacturer, because everything was set up when the Edge gateway was set up and when it was linked via that. But for this, we needed to use the CODESYS Development System. Only Windows capable, huge installation. Can we do better? And of course, it's a rhetorical question. Of course is the answer. It can be better. Just imagine we are in our browser and we use the app switcher, and we could say, okay, go. And the application isn't opened in the development system, but here in the browser. And what this is all about, my colleague Kevin will tell you. Kevin, the stage is yours.
Blick vorne.
Thank you very much, Martin, for passing on the ball to me. No, this is what we call CODESYS v3 is a development environment that only runs on Windows desktops. This programming system cannot be operated in the cloud so easily, and of course, web-based Surface is missing in order to integrate into the automation server, and this gap is something I would love to close, and therefore we develop a new programming system that suffices to those requirements. And this development has a new, you heard it, and we call this new generation CODESYS Go. In the next 30 minutes, I would like to show you the common topics and also the differences between the different CODESYS products. And I would like to talk about the fact that with the integration of the automation server is not the only scenario, but we also have other scenarios in mind. Before deep diving into the technical details, please follow me to a journey. I would like to demonstrate CODESYS Go to you, ladies and gentlemen, using a live demo. And I want to show you what we have achieved up to this point, what the current state is. Here you can see, let me just get rid of this little bar at the top. It's not working. Let's just leave it then. So you see a Chrome browser surface and an empty CODESYS Go developing system. And of course, I start to open a project. And here we see the first relevant difference to CODESYS v3 or a further development compared to CODESYS v3. In CODESYS Go, we cannot only open a project, but an entire workspace. In CODESYS Go, you can open and edit different projects in one instance. This is something which is very good for library developers that basically were used to the fact to have different CODESYS libraries open at the same time with the source code libraries and the codes. You can all combine everything into one workspace and then open it with one mouse click. And let's do that. And here we have a workspace that consists of a project and different source code libraries that are part of my project. Let me just talk about this project. Here in the front, we have a light that we basically controlled. We have the Raspberry Pi as a controller. We have an EtherCAT field bus connected to it with some digital inputs and outputs and an analog input as well. And I'm going to show you that in a second, what we can do with it. So it's not a super great application, but to demonstrate a new programming system, it's quite well suited. Let's have a look into this project. And here you can see some common points with CODESYS v3. At the very top, we have the device node, then PLC launching, application, and down in the tree, we have the programming options that you know from the IC 64631. Nothing has changed basically compared to v3. Currently, we're supporting all textual languages of the IC, meaning building blocks and structural texts, then data types, global variable lists, and everything that is textual. So I think this is nothing new, nothing overwhelming, and I think being in an early stage of a programming system, this is something we can expect. But I would like to point out to the following. In this early stage, we also thought or bear in mind the graphical programming languages. So I have one building block in there, which is in the ladder. And you see that all graphical programming languages are integrated in the programming system, so that at the end of the day, we have the same scope of functions that we know from CODESYS v3. Except for that, you see, all in all, it's a quite lightweight development environment, and this resembles the zeitgeist, basically. You know, just like Visual Studio and Codes, they are basically more lightweight and not over-freighted and overloaded so much as you know it from the old and traditional environments and developing environments. When it comes to the new development environments, we also have a look at usage and usability concepts. For example, we integrated for a quicker commands, we have a command center, and Shift Control C, using that shortcut, you can open it. So a window is open, so you can just enter a command with your keyboard without using or having to use a mouse. And I want to use this feature in order to show you the next novelty. I want to switch my surface, my screen in the dark mode, and as I do not want to deep dive into deep dialogue options, let me just enter dark, and you see the list of the possible commands that start with dir reduces to basically the command set field to CODESYS to dark. So I selected, and you see in CODESYS, just from the very beginning, we have support for dark display integrated. So it's quite an everyday usability feature that you as a developer basically you want to have it. So that's the reason why we have that at the beginning, and because it's quite fun, let me just switch it to light, so the opposite again. And I basically managed to cover two things in just one go. So what would be a programming system without the opportunity to be able to download and translate it? So, of course, we can do it via the context menu, but I really love to work with the command center, so I actually just log into the application with this command center, and here you can see here the compiler is running through it. I had to authenticate against the controller, as you could see, but the browser basically entered the password automatically, and if that wasn't the case, I have it in my pocket, jacket pocket as well. We don't have an online mode in the editor yet. We've not managed to finalize that for the Technology Day, but this is something that will come quite quickly. We have a watch list in the bottom, so let me just enter a variable that I want to observe and monitor. Unfortunately, the one with the longest name in the entire project, but never mind. A log value, so I selected the application, and you see that it is monitored. And if you just keep your eyes on the screen, so I have the analog input, and what happens if I turn it to the right, the value increases, and if I turn it to the left, it decreases respectively. So this is just a proof that it's not a fake, what I'm going to show you here, what I'm showing you, but that it's really live and real time, and it is connected with the controller. So let me just zoom into this tree. It's also a feature that you get basically for free because of the web surface, so that you can zoom in order to make things more clear. You see here just behind in light gray fonts, it looks like a file extension, right? And that brings me to the next topic, basically, this fact. And I would like to ask the directors basically to get me back to my presentation slides. So what happens is we change the way of dealing with project data and also the format for Go. And I would like to summarize what the situation in CODESYS v3 was. You know it yourself, in CODESYS v3 we had one big single binary file in a proprietary format. Rumors have it in the industry that it's a zip format and a zip archive, but I can confirm that this rumor is true, you can try to unzip or unpack a CODESYS v3 project with this unzipper, but what you will see is strange names with strange formats. So basically nothing that you can use as a normal human being. Also, the way of how we process data internally is something different. So what we have internally is we have a transaction-based synchronous changes. So whenever you do something with CODESYS v3, whenever you push a button, it could be the case that internal mechanisms need to adjust other project components. Everything takes place in a transaction and takes place synchronously. And that basically guarantees that we have consistency at every stage. So the consequence of that is that external changes can only be realized through different functionalities. So you can't just open an editor and just save it and then everything continues as normal. You can only use functional interfaces. So in CODESYS v3, we have two opportunities for that. The first one would be the automation platform. You can write a proper plugin and get access to anything in the project. And if you want to have a lightweight solution, basically, we offer the CODESYS Python scripting interface with which you can also realize and execute changes. Basically, we are satisfied. We've been satisfied with this product. Well, for almost 20 years we've been doing that, and basically it works quite well. But what we've seen just recently is that the software environment and landscape has changed. In times of continuous integration, a programming system is not the sun in the solar system anymore. We have external tools that also work with our source code. Just one of the best examples, I would like to mention the version software Git, and it doesn't know anything about our file format. Git doesn't know anything about our consistency requirements, and Git just sets conflict markers in just individual positions. Git doesn't refrain from, just doing one after the other, just instead of waiting for one transaction. So don't get me wrong, ladies and gentlemen. In CODESYS v3, we have a very good connection to Git with our interface, but internally we have to use a lot of effort and force in order, just to get hold of Git and what Git basically can do to the system. And as there is a new development or programming system to be developed, the question is wouldn't it be better to be more cooperative with those tools in order to have fewer problems in the field and also to be able to work with better standard tools? In CODESYS Go, we basically do everything what we can see on the left-hand side, just the other way around. So we just have one file per object in a folder structure. And I'm going to show you that in a second, so I'll just go through that point here very quickly, and you will see it in a live example. Wherever possible, we are text format based. It is not astonishing that we save structured text in text. When it comes to the contact that we saw, well, we also save it in a JSON format as well, but I'm going to show you that in a second. Of course, when we integrate visualization and we have a bitmap file, okay, we leave it as it is because, there's always an end to different things, right? In Go, we also allow asynchronous changes, also meaning that a project can be inconsistent. And if we can't repair it ourselves in the tool, we can notify the user saying that there is an inconsistency just in a compiler notification or something like that. And as we have an open file format, the user may be in the situation to repair the error. That helps us to achieve external changes with standard tools. This is what I'm going to show you in the next live demo. So as you can see, we are back on my screen. Let me just push my CODESYS screen to the side a bit and let me open just a random text editor and open that. So you can see it here where the mouse is hovering over. We have the so-called Explorer, the file system, and here we have the textual content. And as you can see already, this file structure that we have and also the nomenclature of the files represents what we can see on the left-hand side. Well, of course, there are some exceptions, but because of different reasons, so file system and file system, etc. But basically, you have a high recognition value. And in this third-party tool, I can also rename different things. For example, the variable lists. I can rename that one. And if you have a look at the left-hand side to global GLF in the tree, it was changed as well. So the change in the file system is mirrored directly in our system. And also if there are any changes. For example, if I just make a debug count plus 14 and change it to 1447 and click on save it, you see that it has changed immediately. So now I try something that I've never tried, so I hope it works. So I want to have this kick, as you may understand. Well, I feel so comfortable with you guys. You're an amazing audience. And now let me try something. Let me try whether it works with the ladder or not, because I've never tried it. So here, on this side, let me just zoom in a bit. So we have the contact, so disable, and we have the JSON representation of our block. And there you can see, oh, here it is, the disable part. And let me just change it to enable and see whether it works or not. So it has not worked. And that's the thrill about the whole thing. But let me just close the window. Probably the reload is not working properly. Enable. Okay, so that was enough excitement for today. So the rest basically needs to go as planned. No, but the idea behind is that we can use external tools to edit project data, also graphical programming language, and of course, we can do that with all the other project types as well. And I think this is a very important and also philosophical further development of how we would process project data. I have another small surprise, a little anecdote. I was told that I should not show the new stuff only, also CODESYS v3, at least once. We should see it on the screen here, so that you can see that this is our main product, our most important product. And I would like to follow that order, of course. So you can see CODESYS, but of course I have a plan with it. So File, Open CODESYS Go project. Well, implemented in a prototype way, of course. So I select my project from the CODESYS Go environment. Let me just answer some, well, not so nice questions regarding data compatibility. And you can see the CODESYS Go project in the v3 environment. And here again, let me just prove that everything is real and right. So let's just change the debug count back to 1. Now the window on the left-hand side closed. Well, basically, it is closed when you do it in CODESYS, so I have to reopen it again. And here we have number 1. So also with CODESYS v3, I can edit a CODESYS Go project. And that brings me to the next topic. So we have to go back to the slides. So what does the migration path look like? Whenever we talk about new software versions, you have to ask yourself, how do you get all your existing stuff into a new generation? And one thing is what you could see. So we start with a V3 project. We can use an expert to export that into and to create the Go project structure. So you saw many libraries in my demo. Well, what we did is we basically converted them automatically. So basically there's one way from V3 to Go. There is no way back, because with both programming system generations, we can work on the Go project structure. Projects are, of course, not the only data type or project type, of course. We also deal with compiled libraries, device descriptions, etc. And our approach here is that we want to remain compatible. We do not want device manufacturers or library developers have to maintain projects of 2 generations, but one that can be used for both generations. What is also important is the control of the runtime system. The control side will remain 200% compatible with CODESYS Go. You can program every V3 just as of a certain software version. We will hear something about virtual controllers, which do not exist basically anymore. They can also be programmed with CODESYS Pro. Basically, we don't care when it comes to technological issues. Okay, the question now is, how is CODESYS provided? What's the installation method and the operation method? To show you the different options, let me just sketch the different architecture. Well, of course, we didn't reinvent the wheel. So we have, at a central point, we have a backend process, and this backend process is also master of the data. So projects, libraries, device descriptions, they are all in a file system on the backend side. The backend is the only part that has access to the controller. Well, that's a great thing for the IT world, because we only have one access point into the controller environment, and we don't have to drill every controller unit through the firewall. The backend process hosts a web application, and whenever you come and have an end device, and when you connect your browsers to the backend process, to the specific address, the web application is loaded into the browser context, and this is then eventually the surface, basically what is displayed. You see on the right-hand side, we are platform independent, 200%. The only thing that the device needs to have is browser access. It could be a traditional Windows laptop, MacBook, Chromebook, iPad Pro, also a phone, but I don't think that anyone wants to make letters on your phone, but we could if we had to. This basic architecture allows us to play around with it a bit, to have specific installation scenarios. And the traditional case is that we have the backend process on a server. It could be just alloy or aluminum, whatever, just in your own server room. It could also be on premises, but it could also be on a public cloud. Basically, it doesn't matter technologically. The advantage of that is the CODESYS installation needs to be administered just once. You all know it, CODESYS installation takes long, needs a lot of space, has many libraries, device descriptions, thousands and thousands of things that need to fit on every developer's computer. And with this approach, we have the opportunity that we only have to do it once in a local central place, and everyone with a random device basically can just connect and has the right developer environment. We can also add more to that. We can not only have the backend process hosted on any server, we can also integrate it with the automation server. And this is basically the bridge to Martin's presentation. As the automation server knows everything about the controller's network, it is very simple and easy to implement the vision that was just announced. You have a controller in front of you, then you click on programming, and the right project and the right tool version, which is just exactly the right environment, is opened up. And you don't have to have a tool installed locally on your computer in order to do that. The next case is a bit boring, I have to admit. The backend process and the web frontend can be bundled together in an EXIF file and can be opened on a Mac computer, a Windows computer, just as you know it. Then you have a local installation, start menu access, so everything would be as you know it. So this rollout scenario is also something that we support. What is even more exciting is the next bit. The backend process can be put onto the runtime system, and by doing this, you get, I think, a great opportunity to have a programmable controller, to have it in the network, and to enter the address of the PLC and to start programming right away without installing any tool, with just the right communication settings, with just the right set of libraries, etc. I think there will be no easier way. At the end of my presentation, I want to give you some anecdotes on how this technological transfer from V3 desktop world to the server world is conducted. Well, you may remember 5 years ago at this point I had a presentation where I talked about the Lego modules. So just trying to explain to you how we make a server application from the V3. My opinion back then was quite naive. I have to say we are now a bit cleverer. We have to look at those different points in a different way, and I would like to do that at this point. So we have some CODESYS components. We just took them out, and I want to show you and tell you how we did it. Let's start with the application frame first. So we did it ourselves. So we developed it from scratch ourselves. Well, of course, there are always internals and externals that say, why don't you just integrate yourself into Visual Studio Code? Everything is ready to go there. There are some technological obstacles because a CODESYS project is a bit different compared to another project. The best excuse, though, is the software basis of our architecture is something that we would like to be master of, and we don't want to be dependent from third parties. This does not mean, though, that we don't use what is out there. The text editor, for example, that we saw, is just exactly the same editor that you know from Visual Studio Code. So this partial project open source is called Monaco and can be just perfectly put onto structural texts and the IC 3631. And we basically get the best things for free, and of course we use it as well. The ladder editor. If you listen to Mr. Schirmann on the info point carefully, we are developing new ladder 2.0, and those two variants are identical to 95% because we knew that when we started ladder 2.0 for desktop, we need something like that for CODESYS Go. So because of that reason, we made the architecture such that it fits both worlds. Only the last mile for sketching the development of the networks is still different, but this is just a minor bit of the entire source code. So what we try to do in the future to think of both generations when we develop new things. then the compiler, the heart, the core of it. Our compiler is good, it's fast, it's thoroughly optimized. Every day many colleagues deal with the improvement and of the compiler and make it more performant. So we would be stupid not to use this compiler and do something new for the CODESYS Go. That's the reason why we gave a new process shell for our compiler, and whenever we develop it further in the V3, we benefit from it in the framework of Go. A similar thing could be said about online services, but we found out here that desktop implementation is so desktop dependent and not suited for asynchronity and different options. So that's the reason why we decided to make it new from the start. And you see here those exemplary 5 components. You see that we still play Lego with our existing product. But nevertheless, we consider them quite in a differentiated way when considering one component after the other. Let me just get to the end and tell you what comes next. What is on the agenda this year? And I want to tell you one thing at this point. You will not be able to get access to CODESYS Go this year. We are not ready yet, so I have to say that it's not the case. So you may have seen that we still don't have an integration of field bus configuration. This EtherCAT basically was manually programmed to this device with our libraries. But this is, of course, something you will not work with in normal life. And this is the way you don't want to configure your field bus in that. So this is a topic that we will have to deal with, i.e. how can we integrate the field bus configuration to Go. The new automation platform is also a topic that we need to approach. In CODESYS V2, we have the opportunity to develop add-ons and plugins in order to extend the program. Of course, we need to have a similar concept for CODESYS Go. Because of this open project format that I showed you, many interfaces are erased and everything will become, well, simpler and easier. But on the other hand, some challenges are added. Very easy features, nevertheless, need to be separated in the front end and the back end. And where this journey will lead, something we don't know at this point. So we have to think about that as well. And last but not least, I don't know how much it will cost. So how much will it cost to put the backend onto a controller unit and make a PLC out of it? We like to create a basis, a foundation first, and then think about a business model afterwards. So this is something that we don't know at this point yet, this business model. What I know, nevertheless, very, very well, is that it was just a lot of fun to be here with you. Thanks for your attention and the interest. And I would like to pass the ball back to Martin. Thank you very much.
Well, thank you, Kevin, for your presentation about CODESYS Go. It was very interesting and lively. Let us now stay with that framework, CODESYS Go's cloud. And let's look at the next slide. You will recall that the CODESYS Automation Server is fully cloud-based at the moment, which has numerous advantages: high flexibility, for example, easily accessible, cost efficiency. But there are also reasons, such as data protection or compliance requirements, that are obstacles to the use of the automation server in the cloud. And here it would be convenient if on-premises use were also possible in an isolated company network, shielded from the internet, maybe linking different locations on their own independent servers and hardware. And as chance would have it, we have such a server system here with a Linux server on which the automation server is running on premises already. And let me now show you on my computer what that looks like. The automation server was transformed, and in order not only to use it, but also manage it on premises, we developed an apps tool. Switching to the computer, please. Thank you so much. We see the browser-based surface or interface, browser-based, and on that server we can see a Kubernetes cluster, and there are numerous definitions. Different versions can be stored. And using the drop-down menu, these versions can be fed in. So you can have various versions of the automation server, updated, upgraded, or downgraded if necessary. Within such a cluster, many tenants can be created. They are completely independent from one another. For example, if you have various clients and want to associate individual tenants to these clients, or if you have a testing and a productive automation server. Of course, you have the backup restore functionality in order to save the entire cluster with the tenants therein, so you can schedule backups for regular backups, and via notifications you can also schedule downtimes for all users so that nobody's taken aback. Given that we have one on-premises automation server running, let's take a closer look. And maybe you noticed before when I passed the ball to Kevin, the on-premises automation server was briefly seen. There are some entries on the left-hand side, for example, virtual devices. Sounds exciting. Let's see what is behind it. Virtual device hosts, virtual controls, and virtual edge gateways. And for us to understand that better, let's switch back to the slides and let us take a look at these three terms. If the automation server is used in a classical controller network, it is linked to classical physical controllers via CODESYS edge gateways. And our idea behind the virtual controls is that instead of the physical controls that have been used so far, a virtual devices host is run with any number of controls, and this can then be linked via the edge gateway with the automation server. Of course, this can also be done on one host system, and as a consequence, the network interfaces available can be linked to the controllers so that field devices can also be addressed. Let us have a live look on my presentation computer. Let us switch back. Let's start our trip with the virtual host. First, I have to load a host with which to instantiate virtual controls. We give the IP address, authentications, etc., create a new entry. I prepared this earlier. And then you can also create container images for the virtual edge gateways and the controllers, either in the form of a file picker. Here, a container image could be loaded, or if the path is known, you can also enter it here. Once the images have been loaded, this configured, and we can move to the view of the controller. We take the host, and the automation server will now list all the existing virtual controls. These are 15, and they're all running. And now let us see how easy it is to create a fully fledged virtual control via the Edge button. We pick the image. Let's call it Tech Day. We click on Add. It will take some seconds, and then we'll see that a new controller appears at the top of the list, but it is still in the idle mode. In addition, we can configure the controller, for example, add a licensing server. We can do mapping between ports of the container and the host system. Typically, there are virtual controllers in a container, each with a web visualization that cannot be shown on one port, so you need a mapping of ports. In analogy, mapping between data pathways or paths and the container is possible via capabilities, and with that, the container can get authorities or authorizations on the host system, and with the TAP interface, it's possible to link real hardware. One use case, for example, for a network interface with which real hardware components are connected. You have various virtual runtimes. They all work with one, are linked with one interface node, and then you can have the containers, the runtime versions, and test them. Once the configuration has been made, we can go to the host system and make the controller come live. We click on this controller, go on Start, Confirm, and we see that the mode is changed to running. And now on this server, there is another virtual control running. And we can also have it administered by the automation server via the Edge gateway. In this case, a virtual Edge gateway, it is completely analogous to control in configuration. We can see that. We scan the network. We pick the virtual gateway. We scan. We find the controllers. We see the top controller is not part of the automation server, and we can now add it to the automation server. You remember that I needed to authenticate myself via or versus the controller. Given that this is a new controller and no runtime user management has been run, we need to enter access data. So the automation server now creates a new user management on this virtual control. Once that has been completed, we get a confirmation message that everything was completed, and the controller appears in the list. Here we see the controller in the list. Updating takes some time, and now we can do whatever we do with a conventional control. With this virtual one, we can load applications, do web visualizations on that controller that can be queried. For that, let me open a web visualization on a controller. Now this is open in a new tab, and what this visualization is all about and what else is hiding behind the exciting topic virtual control will now be represented by my colleagues.
Yeah.
Thank you very much, Martin, for the great transition. So the first of all, a warm welcome also from my behalf. So thanks for being here, and that the room is full. We are more than glad that we're here. So the virtual control has been teased the entire morning, basically, also because of the automation server. Now we try to shed light into the dark and give you the details. So Andy, please. Yes, great. So let's have a look at the server. So in particular onto the tablet that we have here. First of all, we see the same visualization that also Martin showed you before. The hardware per se is just normal, ordinary HP Pro Lite hardware of the 10th generation, 5 cores, 32 DDR4 RAM, 800 gig of storage space, 16 Ethernet ports, so really huge rockets. So we have a Linux, a Debian Linux 5.10 with real-time patch, of course, Docker installation version 23.0.1, and everything was trimmed down to real live performance. On the system at the end, there are 9 Docker containers, or 9 containers, 4 functional PLCs, so the CODESYS virtual controllers C. Another controller is controlling the virtual visualization, visualization, and then also brings to the display. On the 4 controllers, we have CODESYS applications, 2 of them with EtherCAT, one against a Beckhoff EK100, and a White Miller OE20 Ethernet device. Then 2 other applications are running on Profinet with an ET200SP from Siemens and an in-device of Bosch Rexroth, an inline coupler. So that was it with regards to the hardware. I think, well, we are a software company, so let's get to the software now. And when talking about software, we have a look at the performance of such device. And when we talk about performance, we have a look at 2 things. First of all, the execution speed, and secondly, the real-time behavior. The execution time is the C application, how fast is that one, but also sending and receiving the Ethernets. When it comes to real-time behavior, it's important that the C task is pulled up or executed just when we actually expect it. When we have a look at the figures, we see the cycle time, the execution time basically is around, I think, 24 microseconds. In the EtherCAT case, very fast that is. What is interesting is the lower area here. With EtherCAT, we have a average transmitting or sending time of 4 microseconds. The jitter itself, we can see at the top, the C task is at max 40 microseconds. Of course, we can also have a look at these values for the ProfiCAT. Here we have the cycle time of just a few microseconds. On average, the jitter, maximum 50 microseconds. So on this system, we have a lot of performance in there. Also, sending of the Ethernet frames is happening very quickly. So as you can see, the performance of the entire device with 4 virtual PLCs is very good already. If you compare it with a native controller, you can say that with the server system that we have here, you can basically replace 12 native controllers. Well, 1 controller for every core of the server. Well, that looks quite promising, I think. So we can see that virtual control instances basically are as good as just native ones. And of course, we can see in many areas that we have big advantages of the virtual controllers compared to the traditional ones. But we will talk about that later. The word virtual has been used inflationary today. So you have to go through that, and you will hear that much more often as well. The question which is important to you is, what do we understand with regards to this term? Because every company basically can define it themselves. So now let's take time to introduce to you what we at CODESYS think that term means. For us, 3 main characteristics are important in this definition, and we want to have a look at those just now. The first, and I think the most important one, is the containerized runtime. The runtime system is totally insulated from hardware and operating system. The communication to the outside, to the periphery, works through virtual networks and switches, but of course, it is not a problem to have real physical hardware to connect it to our virtual control system. So from the containers, the basic structure often looks like this. So You have a type 1 hypervisor, which is optional, of course. So if you want to have several operating systems, this is what you need. In our case, usually it's a Linux distribution. You can use different ones, well, Debian, Red Hat, SUSE, whatever you want. And on this Linux distribution, there is a container engine running in the container instance, for example, that could be set up on Docker, for example, in which the runtime of the virtual control works. The second important component of our definition is licensing. We actually use network licenses. So the advantage is that we are independent from the hardware and the application. So that means the license is not depending on the hardware, the components. So you're very, very flexible. And if new instances are connected, you can license them right away. So it fits perfectly to our virtual controllers because we have a high availability. We heard in Martin's presentation before that it is very, very quickly to create controllers in a container within just a few seconds, and such a license is a very good benefit of it because the instance can be licensed just as soon as it was set up. The third very important pillar in our definition is our new business model. It will no longer be based on hardware, but it will be used regarding the complexity of the application. So this means that the price of a license will no longer be based or dependent on the performance of the device, but on the functionality of the software. This is quite reasonable because our runtime in the container is, well, no one knows basically what hardware is underlying, so this is the reason why it would be very difficult to have the license based on the hardware. The applications will be assigned to different classes according to different criteria, such as the number of field buses, I/O channels, and also the code size. Small, simple applications are then very cheap, inexpensive, while large and extensive projects will have higher prices. So we hope to achieve a fair and flexible pricing where you basically only pay for what you actually use as a user. So now we know our idea of virtual control, and Andy will continue with the advantages. Yes, we have a lot of advantages, and the first, and I think one of the most important one, is the independence of hardware. So software and hardware, they are separate from each other. So that means software provides functionality and hardware provides resources. The advantage of having software and hardware separately is that you can expand them individual as well. In this case, we talk about a hyper-convergent infrastructure, and we heard this buzzword before. This infrastructure makes the entire system very scalable. So software and hardware separated independently from each other means if I need more resources, I can just expand it whenever I want, without the software being affected. On the other hand, software is hardware independent. So I can run it on an IPC or also on native controllers. So I'm very flexible in this respect. So that means the system is not only flexible, but also scalable at this point. Because at any time, as soon as we have the resources that can be extended, I can have new and more instances without any delivery times and having to order anything. Everything is very cost effective because an over-dimensioning of a controller is not necessary anymore. So that means whenever I buy a controller today, I buy a bit more CPU for future tasks, so more RAM, etc., to be prepared for future tasks. And this is not necessary anymore when we talk about virtual controllers, because at any point in time, the hardware can be extended. So here, planability and also cost-effective efficiency is improved. Another point that we heard this today is security, the security topic. Not only because of the new EU directive, it is an important topic. By isolating the software in the container, this software only has access to those resources that are passed in from the outside. So that means even if the software in the container is attacked successfully, only those resources are affected. So that means the host system is protected, which in turn increases the robustness of the overall system. Another topic is the IT-OT integration. This is also a term that we hear quite often. From an IT perspective, a container is just a structure that has a specific task, and this is our control as well. So that means that all IT management tools, processes, security, everything that I have built up for my IT infrastructure, all that can be used for the processing of the virtual structure. This opens up totally new opportunities. It also affects orchestration of tools. So there are tools that are used for orchestration, OpenShift, Red Hat, Kubernetes, or vSphere of VMware. All those tools work very well together with our virtual controllers. But also the runtime system is important here. Well, we have a runtime system in the container, but also the runtime system can be learned, basically. So the runtime system in the container offers all functionalities, whether you use them or not. In the future, a runtime system can be basically split down into different services. That means, in turn, that a service that is not needed, for example, the online communication to the programming system, if I don't want to communicate, I can just, boot down or switch off this service. For once, it saves resources, and another point is you cannot be attacked that easily. Another important topic is maintenance, maintainability. IT-OT integration is also supportive in this respect because everything that IT uses nowadays can be used and continue to be used. Last but not least, the installation of a virtual system is way easier because if you have such a concept just once, you just have to connect a hyperconvergent system to it, and then you're done. And nowadays you have to wire all different devices. So you see there are new opportunities basically that we have. I dare to say it's a revolution of the controllers technology. Well, this, of course, virtual controller is an innovation from our house, but we deliberately do not want to talk about a revolution. Hardware-independent controller systems is a CODESYS typical, basically. So you can also say it lies in the DNA of CODESYS to be hardware-independent and to work on different controllers. Virtual controllers, however, go one step further compared to the classic soft PLCs, which has been one of the centerpieces of the CODESYS portfolio for years. Hardware and software are more separate than ever before. And well, you can have your own system put together just as you wish. So starting with the hypervisor from VMware or Acorn to the operating system with Ubuntu, Red Hat, Debian, to the orchestration, also with OpenShift, Rancher or vSphere. Everything is possible, basically, and can be adapted to your own framework conditions. And despite the fact that it's a totally new system, it is fully integrated into the CODESYS ecosystem and completely be compatible with your existing applications and projects and can be used with them. Virtual control as a containerized runtime is, on the one hand, just a runtime in a container, but at the same time, you have new possibilities that were not feasible with previous solutions. So we do not want to speak of a revolution in control technology, but rather of the next logical step in which software and hardware are further abstracted. So basically the next evolutionary step of software. But this is enough with regards to background, advantages, disadvantages, and so on and so forth. Now let's have a look at how we think virtual control can be used in practice and where the use cases are. Exactly. And we would like to have a look at the very important use case, so replacing native controllers by a virtual controller. And as we heard a lot or something about cars before, let's stay with this topic so I don't have to make a new introduction. So we can see here many, many different steps in the production line of a car. So we have welding, painting, assembling, and so on and so forth. But the core element is that there is a PLC at the part of the production line. Everything is tested, everything works well as well, but there are also disadvantages coming within. So maintenance, for example, you need staff. The staff needs to walk to the PLC, to the part of the assembly, and needs to make adjustments, needs to replace devices, and so on and so forth. This involves quite a lot of effort, and also with regards to updates. The process is the same. You need to have one person that goes there and does it. Another point is the dependency of the PLCs. So the last few years have shown that when you depend on supply chains, you either have to have PLCs on stock, you have to calculate downtimes or waiting times, or you have to plan redesign processes, no matter whether it's for the hardware, for PLC, or for other things. And this is what we do not have with a virtual controller. So virtual control takes place on site. The installation is very easy. It's because you can use your IT processes in order to install it, to update it, and in order to create instances. The performance, as we could see, is basically in an area where you can compete with native controllers, and you don't have any supply chain issues. Well, the question that many of you ask yourself is, what happens if all the centralized software just comes to a standstill because one server, just is not running anymore? So is the entire production hall standing still? That's a good question. Well, of course, not really. It's not a single point of failure because we offer a solution to that. Our CODESYS redundant. So today, I can have a virtual control run in redundancy mode. So I have an active and a passive mode. And if the active control, for example, because the entire network, has a default, the second control takes over. Well, it doesn't take it over only, but just right away. So we have a very good system because the control is run every time, no matter whether we have an update or if we have a default or a failure. So when we have an update, for example, then the first system shuts down and the second system takes over. So you see, it's a 360-degree solution, but one part is missing. So what about safety, Nikki? Well, we also put some thoughts into that topic, and we are working on how we can implement it for virtual controls. But before we get to that, let's have a look at what the approach is at current controls. Well, most of you may know it, but I would like to explain it so that everyone is at the same level. We basically have a two-channel hardware. Everything is calculated on that, and then the results are compared, and this ensures that no random errors can occur. Our developers at the moment at CODESYS are currently working on a solution that is hardware independent, so that means there is no special two-channel safety device that is needed. So the virtual safe control, just like the virtual functional control, should be able to be operated on every hardware, so we are totally flexible. The concept looks like this. So we start with the normal safe control as the basis, and we use this special safety hardware and take it away. So the synchronization of the two channels is no longer needed, so we just erase that as well. And from this parallel work-off that we usually have, we make it a sequential one. So that helps to prevent a stacking of errors. And the good thing about our process is the data of one channel are transformed and calculated in a different way than it was the case in the previous channel. This coded channel, there we have some faults, and then we have a process control implemented with which CPU and memory tests can be replaced. The results are then retransformed compared to the previous channel, so similar to the normal safety hardware basically. And the safe software doesn't have to run on specific hardware, but it runs and it is operated in our container, therefore being independent from hardware because the software doesn't know which hardware is the underlying one. This container then is based on a Linux distribution, which in turn is also on the hyper-convergent infrastructure, just like the functional controls. So it's totally integratable in the concept where just normal, in inverted commas, controllers are operated. So random errors are not detected by two channels, two-channel hardware or two-channel software, and the calculation of this second process takes place by a coded software system by our partner, and the advantages are the same ones that we have with the functional virtual control. So just like what Andy said, the scalability, the simple IT integration, the flexibility, easy wiring, maintenance, etc. Another very, very important advantage is that compared to normal safety controls, you don't have a TÜV certification according to IEC 61508, but just only acceptance according to the machinery directive. So that means the certification will be way easier in a software, in a virtual environment than in a hardware environment. This concept has already been tested and approved by the TÜV Süd and is currently under development in our premises, at our premises. So the goal is that virtual safe control will be just as easy as the convenient one. And of course, everything is still in the development phase, but we have a prototype with us today, and let's have a look at the prototype and what the performance is. Let's get back to the tablet. So here we can see the setup again. We talked about 9 containers at the beginning, 4 were missing, and those are our safe controls, basically. So that means we have 2 applications running on it, 2 with FSOE, with EtherCAT coupler, and 2 with ProfiSafe for the ProfiSafe coupler. Except for that, it is running on the same infrastructure, first and foremost in the container. Now let's have a look at the performance data. Well, I was getting a bit nervous when Dr. Löser had his presentation. Well, 8 milliseconds. Well, we see cycle time 5 milliseconds and the round-trip time 10 to 50 milliseconds. I think it's quite good for a prototype. We have a configured cycle time of the safe control of 5 milliseconds. So that means the program is worked off every 5 milliseconds. The maximum cycle time or round-trip time for EtherCAT is at 40 microseconds. And with Profinet, we have similar values. 5 milliseconds as a cycle time. The protocol is ProfiSafe, not FSOE anymore. And the round-trip time is similar to the previous one. So we've not reached the goal yet, the target yet, but I think we are in the right direction. Exactly, and based on the state of current development, so the prototype, it looks quite promising, I think. So just for the end of our presentation, let me just take the time and summarize what we had. I wanted you to understand what the most important points are for today. The virtual controls, no matter whether it's functional or safe, they offer very flexible, highly availability and very cheap and good solution, safe solution that, although everything seems to be quite new and innovative, can be combined with your projects and applications, and it can be integrated in an existing ecosystem. Many of you that are interested in virtual control and are potential customers or want to be potential customers, you may ask yourself, okay, when will virtual controls and virtual safe controls be released? We plan with a release in the first quarter of 2024. And with that being said, I want to say thank you for your attention. Enjoy the rest of the program, and I hand back to Martin and the Automation Server. Thank you very much.
Vielen Dank, Niki und Andi.
Thank you, Andy and Nikki. You left off on the topic of safety, and I want to stay with that topic, but not safety, but security, Sicherheit, both in German. So, with all the vectors, or attack vectors, IT security comes to the fore more and more, and we have set our goal to make certificate management as functional, convenient, and easy to create as possible. And let us now take a look at what that looks like in the Automation Server in a demo. We see the GUI, we see another menu entry called Overview, and this overview shows all the certificates of those controllers currently linked to the Automation Server. We can then refresh the view, then all controllers are queried for data, and here you also see the controller that we created earlier. Refreshing can also be automated. That can be configured that the data is queried from the controllers cyclically, but that just in passing. In the overview, we see the existing certificates and controllers, and I will filter for the new controller, and we see that on the controller there is a certificate. We see that the certificate is only valid for 1 month or shorter. You can see that given that it is orange, red would mean expired certificate, and we see that the controller certificates is used for 2 things. Now we can very conveniently replace the certificate that will expire within a month by saying we want to create a certificate for the Tech Day controller that is to be used for Tech Day. Then the CMP web server is also queried. Add and refresh is required. There is pairing, and we now see a new certificate was generated that is valid for 1 year by default, and this also can be used for both scenarios, and the previous certificate will no longer be used for these scenarios. With the Automation Server, we can also download the certificate and look at it with Windows. So the window typical certificate view, we see it's a certificate issued by Tech Day. For Tech Day, a self-signed certificate 1 year from today is expiration of validity, and we can also look at other details of the certificate. Of course, we do not only have the option to download certificates, but also upload a certificate. That works with this button. Here I've made a certificate, and we can now select where the certificate is to be stored. For example, in the quarantine folder, I need to refresh the view because I don't have any automatic refresh, and we see that there is an additional 3rd certificate in the quarantine folder. This was just a foretaste as regards certificate management with the automation server. And up until now, we have seen a great many good functions, but also not just any person should access these functions, or especially with regard to security. So we have always had user management and a very sophisticated, comprehensive authorization management. It is easy to manage, but sometimes you need additional functionalities. So just imagine you are in a large company with hundreds of thousands of employees. New employees join, others move to another department with new tasks, and all that needs to be reflected with review to use and authorization management. As a rule, you do that via directory services that are centrally managed by company IT. A prominent example is Active Directory of Microsoft, or OpenLDAP, a open source software. There, data is made available that can be queried from other applications, and with this central directory service, you can communicate in various ways. And for LDAP, Lightweight Directory Access Protocol, is the industry standard. And here it comes around full swing, because it has shown that it must be possible to centrally manage users by IT, especially in large companies. And for that very reason, the automation server will be able to speak LDAP. Let's take a live look. Let's switch to user management. And here you see the settings of the existing system, plus a tab called LDAP settings, and there you can activate communication with LDAP with a superior directory service. And here you can link the directory service via host name, IP address, or port. And you can also indicate a user that is authorized to work there. And once this configuration has been concluded, the automation server can talk or communicate to a subordinate directory service via LDAP. Let me give you an example here. For that, I would like to change to this group. Within the automation server, I can add a new group. Let me say the group is Tech Day, and I would say this group may do everything. And correspondingly, the automation server gives it the authorization of an administrator. Now, if I tick the check boxes, I can link it to LDAP available groups. Down there, I can include existing users, Angus MacGyver, Huckleberry Finn. I added get an overview. A new group will be created that is almost called Tech Day to existing users. And then you have a link to the LDAP group. Then you have a new group. Now, what does that mean? Once a user that is in the directory service but not linked to the automation server tries to log on to the automation server, a user account is made for the user, and this user has the rights in accordance with the group, those of an administrator in the automation server, and the authorizations as per definition of IT. Of course, you can also do that for individual users. I don't want to show you that anymore, but I would like to show you one last feature of the automation server for the future. You recall that dashboard view. In future, the topology view will allow mini dashboards to be created, and there you can have a controller-related live monitoring. So you can have various parameters, process parameters monitored and look at states. In topology, it will also be possible to include map services like OpenStreetMap or Google Maps, and then you can include the coordinates, and then it's possible to move to the controller details by a click. And now I have two very special maps for you. It's past noon. If you start from your place in Codebox and take the escalator up to the ground floor, you will be expected next to the info points by your lunch. And given that I hear some stomachs grumble in the first rows, I don't want to stop you from your lunch. Thank you very much. Have fun with the features of Automation Server. Have great conversations in your lunch break, and above all, enjoy your lunch. We will be back at 1:30. Thank you.